Okay, so after going over the area between two curves, which is two-dimensional, today we're gonna go over 6.2 volumes of solids. In this section, we're gonna talk about two methods: the disk method and then the washer method. But first, the disk method. So, what exactly is finding the volume of a solid? To find the volume of a solid of revolution is to calculate the volume of a three-dimensional object formed by rotating a two-dimensional area. So say you have y equals f of x, you take a cross-section and you rotate it around an axis, usually the x or y axis or any horizontal or vertical line. So you get a solid, and then you try to find the volume of this solid. Okay, so that added component to the two dimension, that added component is obtained by rotating around the line of symmetry, usually the x and the y axis. Okay, and there's an explanation where the disk came from in the notes on pages 1 and 2. So go as just simple example just to go over that, but I'm gonna get to the method. So here's the volume of a solid of revolution. I'm on page 3 now in the notes, using disks. So we're gonna go through several steps. The first one is when we have a two-dimensional area revolving around the x-axis. So if we take an area and revolve around the x-axis, you get something like this. So this is y equals f of x. So this is f of x right here, and over a to b. So the volume is the integral, since it's a disk, it's integral from a to b pi r square dx, but the radius, that's the radius, is f of x, so it's integral from a to b by f of x square dx, where f of x is the radius of the disk. And this is a handout in the notes. Cross section is revolving about the x-axis. This is the formula we did. And then if it's about the y-axis, it's going to be g of y, because the radius would be g of y. So here's the second one. If the cross section is revolving about the y-axis, so you're gonna get, so if you have x equals g of y, and you take a cross section perpendicular to the y-axis and you go around it, so you get, so this is x equals g of y, and that's the radius, and you're going from, say, c to d. So v equals pi c to d g of y pi r squared, and then the thickness is dx, in this case it's dy. Okay, from the formula for the volume of a disk, pi r squared h. So here's a couple of examples. Example 1, find the volume of the solid generated by revolving about, and that's what we should be looking for, x-axis, y-axis, or any other line. The region bounded by f of x equals square root of x minus 1, the x-axis, and the line x equals 5. So you have to draw a three-dimensional, although I did in the notes, but you don't have to. Y equals square root of x minus 1, so at x equals 1 it's 0, at x equals 2 it's 1, at x equals 5 it's 2, so this is y equals, this is x equals 5, this is y equals square root of x minus 1. So we want the area between this graph, the x-axis, and the line x equals 5, and revolving. So since we're revolving around the axis, we're gonna make a cross section perpendicular to the x-axis always. In this method, the cross section has to be perpendicular to the axis of revolution. So this is the radius, which is square root of x minus 1. So v equals pi. The values are from 1 to 5. F of x squared, or r squared dx. So v is pi from 1 to 5 x minus 1 dx. So if we integrate x dx, we get x squared over 2. Integrate dx, we get x from 1 to 5. So that's 25 over 2 minus 5, and then minus pi times 1/2 minus 1, which is 8 pi, and it's a volume, so it's cubic units. Okay. Okay, here's another example. Find the volume of the solid generated by revolving about the x-axis. So we're revolving around the x-axis. The region bounded by the graph of y equals square root cosine x between 0 and pi over 2, the x-axis and y-axis. So let's draw that region that we're going to revolve about the x-axis. Y equals square root of x between 0 and pi over 2, so x is 0, cosine 0 is 1. When x is pi over 2, cosine pi over 2 is 0. So, and then pi over 4 is 1 over root 2, so it's somewhere here, so you're gonna get somewhat like this. So we want the region bounded by the graph of square root of x, this is square root of cosine x, between 0 and pi over 2, the x-axis and the y-axis. So we're looking for this, and we're revolving it around the x-axis, so we do a cross-section perpendicular to the axis of revolution, and we go like this. So this is going to be the radius, which is square root of cosine x, and we're integrating from 0 to pi over 2, radius square, or f of x squared dx. So pi integral 0 to pi over 2 cosine x dx. Integral of cosine is sine. So the volume is 10 pi over 2 is 1, sine 0 is 0, so it's pi cubic units. Okay, so we've seen two examples about revolving about the x-axis. Let's see now about the y-axis, example 3. So find the volume of the solid generated by revolving about the y-axis. So the axis is revolution, the y-axis, the region in the first quadrant bounded by y equals x squared, the y-axis, and the line y equals 6. Okay, so let's graph that region. So let's graph that region. Y equals x squared in the first quadrant, 0, 0, 1, 1, 2, 4, and the line y equals 6, 5, 6. So this is the line y equals 6, 1, 1, 2, 4. So it goes like this. This is y equals x squared, and so between 0 and 6 we're gonna have a cross section perpendicular to the axis of revolution, and this is the radius, which is, so we need x equals square root of y. So v, because we're doing gy, remember that, so v equals pi integral from 0 to 6 g of y, or r squared dy. So pi 0 to 6 y dy. So the integral of y dy is y squared over 2 between 1 and 6. So you get 36 pi over 2, or 18 pi cubic units. Okay, let's see more examples. Part A, find the volume of the solid generated by revolving the region bounded by y equals 2x squared, y equals 0, x equals 2, along, so we're revolving along the x-axis. So that's part A. So let's see, y equals 2x squared, y equals 0, so this is y equals 0, this is x equals 2, and y equals 2x squared, 0, 0, 1, 2, and then 2, that's 8, 3, 4, 5, 6, 7, 8. So it's gonna be like this. So we want this region to be revolved around the x-axis. So we take a fraction perpendicular to the x-axis and revolve it. So that's the radius, which is 2x squared. So pi from 0 to 2, 2x squared dx. So pi integral from 0 to 2 for x to the 4 dx. If we integrate, pull the 4 out, so 4 pi x5 over 5 between 0 and 2, so you end up with 128 pi over 5 cubic units. Now what if we revolve the same thing about the y-axis? So part B, revolve same region in A, but this time about the y-axis. So if we're gonna go this way, and we go like this, is a gap. So this is not disk method, this is not this section, this is the washer method. It's the next one. We'll come to this, okay? So this is the washer method. Because remember, in a disk, to get a disk, there's no gap. To get, if there's a gap, the revolution, you get what we call a washer. Remember the washer you buy from Home Depot or Lowe's, okay? So we'll talk about this. This is not for now. We'll come back to this. So we've seen disk method by revolving about x-axis, y-axis. Next, we're gonna do if the region is revolved about the line, a horizontal line. Region is revolve about the horizontal line y equals k. So if I take, say, y equals k, could be here, could be there, could be there. I'll just do here for now as an example. This is equal k, this is y equals f of x. So if I take between a and b, if I take this region and I do a cross section perpendicular to the line y equals k and go around the line y equals k. So that's the radius, and the radius here is not f of x, this is f of x, all this is f of x, then we're gonna minus from that k, this is k, to get that. So r is f of x minus k, so the volume would be pi a to b f of x minus k. We put absolute value, sure this is positive because k could be above there, okay, dx. And it's not gonna matter because you're squaring it, but the radius is absolute value, okay? And if region is revolving about vertical line x equals h, then the volume will be, so if this is x equals h and this is x equals g of y, and we're going this way, this is the region from C to D. We do a cross section that's perpendicular to the axis of revolution. This is the radius, and the radius is g of y minus h in absolute value, so the volume would be pi integral C to D g of h, g of y minus h squared dy. And again, these are right here in the handouts that I told you about. Cross section revolved about the line y equals a, and then a cross section if it revolved around x equals h. Okay, and then we'll talk about the washer method, but let's see some examples about these two cases. So example 4, find the volume of the solid generated by revolving about the line y equals 8, the region bounded by the graph of y equals x squared plus 4 and the line y equals 8. So we're revolving around y equals 8, 6, 7, 8. The region bounded by y equals x squared plus 4, so at 0 it's 4, at 1 it's 5, at 2 it's 8, and at negative 2 it's also 8. Negative 1 it's 5, at negative 2 it's 8, so you get this region, okay? And we want to take this region and revolve there, so we're going to take a cross section and go this way. So the volume is pi, the interval from negative 2 to 2, and the radius, you can see that this piece is 8, it's 8 minus x squared plus 4. This is x squared plus 4. So it's 8 minus x squared plus 4 square. That's the radius dx. Okay, that's the radius r of x. So it'd be 8 minus x squared minus 4. So pi 8 minus x squared minus 4, so it's 4 minus x squared dx from -2 to 2. And if you work it out, if you square this, you get 16 minus 8x squared plus x4 dx. So you get 16x minus 8x over 3 plus x5 over 5. Between -2 and 2, you plug the numbers in, and you're going to get 512 pi over 15 cubic units. Okay. Okay, example 5. And the volume of the solid. So volume generated by revolving about line 183, the region bounded by y equals e to the x, the y-axis, the line x equals ln of 2, and y equals -3. So let's find region and then revolve it around there. So y equals 3, y equals -3. The region revolving around -3, sorry, so this should be -3. 1, 2, 3. This is the line of revolution. Y equals e to the x, e to the 0 is 1, e to the 1 is e, which is roughly 2.7. This is 1. You get something like this if you remember e to the x equals ln of 2. ln of 2 is roughly 0.7, so this is x equals ln of 2, which is roughly 0.7. So we want the region bounded by e to the x, the y-axis, x equals ln of 2, and y equals -3. So all this region, and we want to revolve it along the line y equals 3, so we do a section that's going to be the radius that we have to find, because we're going this way. So v is pi integral from x equals 0 to x equals ln of 2, from 0 to ln of 2. This much is e to the x, that's e to the x, and that's 3 units, so e to the x 3 square, that's the radius square dx. Again, this part is e to the x, and this much is 3 units, so we're finding a distance, so you add them then together. So v is pi 0 to ln of 2 e to the 2x plus 6 e to the x plus 9 dx, which would be pi integral of e to the 2x. If you do substitution, it would be 1/2 e to the 2x. This is 6 e to the x, and that's 9x 0 to ln of 2. If you put it in your calculator, it's roughly 43.16 units cube. Okay, so now this is the solid, the disk method is done. Let's look at the washer method. So for the washer, this is for solids of revolution with holes. See, in a disk there is no hole. The washer is formed by forming the washer is formed by revolving a rectangle about an axis. So basically you have, say, f of x, y equals f of x, and then y equals g of x between a and b, and you're gonna take a cross section and revolve it about the x-axis. You can see there's a hole. So when you do this, you get something like this, a washer, and this part is right here, so you're gonna have to find that radius. That's the radius. So you do 5. So basically you're gonna do v equals pi integral from a to b. So you're gonna do the bigger disk, which is the outer. So it'll be pi f of x square dx minus the volume of the smaller, which would be the inner one, pi g of x square dx, which would be written as pi a to b f of x square minus g of x square. We factor out the pi. So this would be the outer, and this would be the inner. Okay, outer minus inner. And now if you revolve about the y-axis, revolving about y-axis, so instead of a and b, we'll just use different values, c to d, and it would be f of y square minus g of y square dy, again outer minus inner. So let's go back to the example that I left out. I told you that's the washer method. Here we go. So in this example, I did part A, which is taking this and revolving it. No, that's different one. That's not part A. Here's that example. Region, okay. Part A, yeah, right here. Find the volume of the region generated by revolving the region bounded by y equals 2x squared out the x-axis, and we got this. Now if we're gonna take this region and revolve it around the y-axis, then there's a gap, and that's why we use the washer right here. So we get the washer. So in this case, v equals pi integral, my y values are from 0 to 8, and the outer function is x equal 2, so it's 2 square, minus the inner function, which is x equal, so it's y equal 2x square, but we want x, so y over 2 is x squared, so x equals square root of y over 2 squared dy. Would be pi 0 to 8, 4 minus y over 2 dy. So it would be 4y minus y squared over 4 between 0 and 8. You plug the 8, it's 32 minus 64 over 4 is 16. You plug the 0, you get 0. So it's 16 pi cubic units. Okay. And so when there's a gap, we use washer. When it's solid disk, we use the disk method. Let's see more examples. Example 6. Find the volume of the solid generated by revolving the region bounded by y equals x squared, y equals root x, about the x-axis. So y equals x squared, 2, 2, 3, 4. So this is y is x squared. And then y equals root x, 0, 0, 1, 1, 2, 3, 4, 2. So this is the region they're talking about, and we want to revolve it out the x-axis. So we take a cross-section perpendicular to the x-axis, and we revolve, and you can see the gap. So that's washer. So v equals pi. So the x values are from 0 to 1. The outer is root x squared. The inner is x squared dx. So pi 0 to 1 x minus x4 dx. Integral of x dx is x squared over 2, and x4 would be x5 over 5. Between 0 and 1 you get 3 pi over 10 cubic units. Okay, let's look at more. Example 7. Again, use the measurement in a calculator to find the volume of the solid. So volume of this solid generated by revolving the regions bounded by y equals x squared, x equals y squared, first quadrant, about, so we're revolving about the y-axis. Okay, so y equals x squared in the first quadrant, 0, 0, 1, 1, 2, 2, 3, 4. So this is y equals x squared in the first quadrant, x equals y squared in the first quadrant. When y is 0, x is 0. When y is 1, x is 1. When y is 2, x is 4. So we're talking about this region, and we want to revolve it about the y-axis, so we're going this way. So you can see that there is a gap, which means it's washer. Even if they didn't tell us, we should know. So the y values, now we're going to do the y value from 0 to 1, and then the outer, inner. The outer is y, but we need x, so x equals root y. So it's root y squared minus the inner, which is x equal y squared. So it's y squared squared dy. So pi 0 to 1, y minus y4 dy. So pi y squared over 2, y5 over 5, 0 to 1, 3 pi over 10 cubic units. You can see that the same answer as the previous one. Okay, example on page 13. I want you to go over that. I'm going to do the one on page 14. Find the volume of the solid generated by revolving part A, the region bounded by y equals 2x squared, y equals 0, x equal 2, about the y-axis. Okay, there's no part A, just one problem. Okay. Okay. So if we graph y equals 2x squared, well, y equals 0 is the x-axis, x equal 2 is the vertical line. We're revolving about the y-axis. 2x squared at 0, 0, at 1 it's 2, at 2 it's 8, 4, 5, 6, 7, 8. So we get this graph. Let's just do it. We want this region to revolve about the y-axis, so you can see there's a gap. That's why it's washer. So pi, the y values from 0 to 8 for that region. The outer x equal 2, so 2 squared minus the inner. Inner is y, but we need x, not y, so y over 2 is x squared, so x is square root of y over 2. It's positive because x is a positive value here, first quadrant. So square root of y over 2 squared dy. 0 to 8, 4 minus y over 2 dy. So it's 4y minus 1/2 y squared over 2, 0 to 8. So you're gonna get 16 pi cubic units. Okay, and that's it for 6.2. 6.5 is next. Let's take a break.